begin. All right. So we just saw with that explore activity that a function that is written using two or more expressions, the one that we saw in the warm-up had three, but as long as there's at least two expressions written for the same function, that's what's known as a piecewise defined function. Each of the expressions is defined for a distinct interval of the domain. We saw that in the warm-up, between 1 and 3, between 4 and 6, between 7 and 9. All those x values will be specifically stated. That way you know where things start and end between those certain sections of your piecewise defined function. A dot or a closed circle is used if a point is included on the graph. It's like doing the greater than or less than or greater than or equal to less than or equal to. You fill it in if it's included, you leave it open if it's not. They're not saying closed circle versus open circle. They're saying a dot is the same thing as a closed circle, and then a circle is the same thing as an open circle. So you just want to do a quick reminder here. Dot, circle. I'm not even going to say, I'm going to say this as well. If this or this, and then circle if this or this. So if it's less than or equal to or greater than or equal to, it's a dot. Circle if it's less than or greater than, without the or equal to portion of that. All right. That's stuff that you know already. Everything that we are doing, honestly, everything that we're doing today, each individual piece of what we're doing today is stuff you have done before. Putting it all together is the new part of what we're doing today. So our first graph is already made for us, but we are going to walk through it and talk about the details here. So it's saying that this function is both x minus 3, which is a line, and 2x, which is a line. It is the line x minus 3 until it gets to 1 on the x-axis. Once it gets to 1 on the x-axis, the function changes to be the line 2x. So we are going to, first of all, figure out the highest value of y for the highest value of x on this first part of the graph. Because the highest value of x for this first part of the graph is 1. Because all the x values are either 1 or less than 1 on the x-axis. So the farthest to the right that this part of the graph can go is 1. Similarly, the highest or the farthest left it can go for this part of the graph is 1. This one goes up to 1, this one starts at 1. So this one goes to 1, that one starts at 1. We're going to. But what we're going to do to get the y value is we're going to figure out where the end point of this particular portion of the graph is. And so it goes as far as an x value of 1. So we're going to substitute in 1 for x. And that's as far right as that portion of the graph will go. So if we plug in a 1 here, that's going to be 1 minus 3. So you're going to plug in right 1 right here. And 1 minus 3 is negative 2. And the function we're talking about, just to make this even clearer, is, I'm just going to write this up here, and I'm going to use a different color. Where's my red pen? There we go. X minus 3 would be y equals x minus 3. That's the equation we're looking at. If you were to graph the whole line without any endpoints, it would just be y equals x minus 3, which means we have a slope m equal to 1, and we have a y-intercept b equal to negative 3. It's like graphing a regular line, except we're not graphing the whole line. We're only graphing part of it up to positive 1. And then for the other one, let's just go and get a little more information here. This would be y equals 2x, which would be m equals 2 and b equals 0. So this one has a slope of 2 and a y-intercept of 0. And we'd be graphing this line. We're just not graphing all of it. We're graphing it starting at positive 1 on the x-axis. That's what we're dealing with here. So in order to figure out the endpoints, though, we do need to plug in these x values to figure out the end point of this one and then the start point of that one. Yeah, Kai. Real quick, Riley. Go ahead, Kai, and then Riley can ask. So we don't really know yet. We're still working through it. So just keep following the process, and then once we've gone through the process, if you have a question after that. I haven't shown you the process yet. So let's go through it first. And then once we're done going through the process for the first time, if there's still questions after that, let me know, okay? Riley?
So the X value that we plug in for X
Yeah.
is always going to be those values.
It should be these because these are always going to be the endpoints in terms of the section on the graph where it is. So Kai, just to give you a little bit more of a heads up on this, the graphs are already made for us on this first one, so I can talk about it in a little bit more detail. So this line right here, I'm just going to draw an arrow to it. This is the line y equals x minus 3. So basically what we're saying here is if we were to draw a line all the way through this and not stop here, if we were just to draw all the way through, that would be the line of y equals x minus 3. Because it has a y-intercept at -3 and it has a slope of 1 over 1. And if we were to continue with this, we keep going up 1 over 1, up 1 over 1, up 1 over. So that's that y equals x minus 3. That's the first part of this piecewise defined function up here, minus 3. And then the second part of it is the 2x, which is this other part to the right. And so this is the line of y equals 2x. If you were to draw that entire line, you would have a y-intercept at 0 and a slope of 2. So you'd be going up 2 over 1, up 2 over 1. So these are regular linear equations. They're just cut off. Yeah. They're cut off at certain points. So they're regular linear equations that have been cut off, and then we're basically splicing parts of two linear equations into one function. That's what's happening. Okay. So in order to figure out where one of those ends, we have to use the endpoint here, which in this case is 1. And so that's why we plugged in the 1 for x, and we got a y value of -2. So that means 1 satisfies the inequality because 1 is part of the solution. Place a dot, not a circle, but a dot because we're closing it in. Place a dot at 1, -2. And if you place a dot at 1, -2, that's this dot right there. It's the one that's already on the paper. So the dot 1, -2 is the farthest to the right that this particular part can go. That x minus 3 line can go as far as +1, which is why we chose 1 for x, because that's as far as it can go, which gives us a corresponding y value of -2. So we can go all the way up to there and it stops. Can't go any further. Because x minus 3 is defined for values of x less than or equal to 1, so less than would be 2 words here. It restricts the domain in that original piecewise defined function by saying x is less than or equal to 1. So all values of x less than or equal to 1. You're going to graph the linear equation with a slope of 1. To which side of the dot? To the left or to the right? If it's less than 1, are we graphing it to the left or to the right? To the left. Exactly. So it has a slope of +1, which means if we were to continue this way, we'd be going up 1 over 1, up 1 over 1, but we can't go that way. So you can reverse both parts of the slope and say down 1, left 1, down 1, left 1, down 1, left 1, and it still gets that same line. So if you wanted to, you could just go backwards with the slope, putting some more points on there, and then your line gets drawn through it. And that is the first part of that piecewise defined function on the graph. Now we have to do the same thing for the second part of it, which is f of x equals 2x for all values of x that are greater than 1. So this one is starting at 1 and then continuing past it in a positive direction on the x-axis. So we're still going to plug in 1 for x into this function here, y equals 2x. So this will be y equals 2 times 1, which is 2. Since 1, though, is not included in this inequality because it has to be strictly greater than 1, it cannot be equal to 1 on this part of it, we are not going to be using a dot. We're going to be using a circle at the point 1, 2. And you can see right here, there's our circle at 1, 2. Because 2x is defined for all values greater, that's the word here, greater than 1. We are graphing the linear function. What's our slope of this part of the function? 2. Yeah, 2 over 1 or just 2. Slope of 2. And does this part of the function go to the left or to the right? to the right. So if you go up 2 and over 1, there's our next point right there. And then you can draw your line through it. And we've put portions of each of those graphs into the same function. That's what a piecewise defined function is. Splicing together portions of different functions into one function. All right. Are there any questions about that process before we continue? Well, let's try one. There's one on the next page. Let's try that. Okay. Because we'll walk through the process entirely again. All right. We're going to analyze some key features now, though. So key features would be like domain, range, maximums, minimums, all the stuff that we talked about from a couple of lessons ago. Y-intercepts, x-intercepts. So the function is defined for all values of x because it goes to +1 and then it picks up at +1 and it just keeps going in both directions forever on the x-axis, right? So for the function here, left and right, it actually goes forever. There's no gap on the x-axis. It goes from -infinity to 1, and then it picks up right after 1 and keeps going to +infinity. So the domain is going to be all real numbers because every value of x is included because there's no gap on the x-axis. However, the y-axis, there is a gap. There's a gap between -2 and +2. So the range is not going to be all real numbers because it goes up to -2, stops, pops up to +2, and then keeps going up after that. Yeah. Oh. You don't, but it is included here. So 1 is included here, but not here, but that means it is included. Yeah, so it goes up to 1, includes it here, and then picks up from 1 and keeps going. Yeah. And then on the y-axis, it goes up to -2, stops, and then there's a gap here that it picks up again at +2 without including 2. Okay. So in terms of writing the domain, you would just say all real numbers because every value of x is valid on this one. But the range, it says, is all real numbers that are less than or equal to -2 because it goes up to -2 and all real numbers greater than 2. So this can be represented symbolically as, right here, we've got ourselves some set builder notation, f of x such that f of x is less than or equal to 2 or f of x is greater than 2. F of x is the same thing as y. So basically all values of y such that y is less than or equal to 2 or y is greater than 2. In interval notation, let's write this in interval notation as well. We'd be going from -infinity to -2 and including -2. So we put a bracket around that. That's that first part. That's what we did last week. One of the lessons had this in it. And then because there's a gap, we have to create that union. So we're going to do the U in between them. And then because we're not including 2 when we pick up, we're going with a parenthesis. And then we're going to say 2, infinity, and then close that parenthesis after. So both of those things say the exact same information. This one is in set builder notation. This one's interval notation. Yes. Yeah, if it doesn't tell you, if it asks you to define the domain and the range and it doesn't tell you what format to use, you could also use just standard algebraic notation. You could say, you could just go with y is less than or equal to -2 or y is greater than 2. You could just write it like that if you wanted to. Algebraic notation, that's fine too.
So we don't have to do this.
No, not if it doesn't tell you. If it says to use set builder notation, you got to do that. If it says to use interval notation, you got to do that. Otherwise, any one of those 3 would be an option. Question, Nate? This one over here? This one. Okay, so it goes down to infinity on the y-axis, and then it goes up to -2 and stops. But we're including 2, so we're going to use a bracket. That is basically everything on the y value from -infinity up to -2, including that, and so it stops there. Then there's the gap, and it picks up again at +2. So here's our gap, and then it picks up again at +2, and we're using a parenthesis because we're not including 2 when it starts to go up from 2. That's why the circle is open instead of closed like that one. So parenthesis when we're not including the number, and then it goes up to +infinity. Cool. Or if you want to use algebraic notation, you can write it like that. So 3 options. The middle one? This one? This one here?
Or 1,
Greater than 2.
2,
Greater than 2. Sorry, the tail on the y got a little out of control there. That's just y is greater than 2. All right. So also the y-intercept is -3 because it goes through the y-axis at -3, and it does not come into contact with the x-axis. There is no x-intercept. Nope, because it does not cross over the x-axis. That's where the gap is. Nope, no x-intercept. The function is increasing for all values of x, meaning it's always going, as you look at it from left to right, it's always going up. Regardless of what section of the functions you're looking at, it's always going up. Okay, let's do this one together. I'm not going to make you do this one on your own, but let's take a look at what we've got going on here. All right, I am going to color code these ones. That might make things a little bit more user-friendly. So I'm going to highlight this first one in pink, second one in green, third one in blue. If you have highlighters or if you want to do different colors for these, you're welcome to do that. You don't have to. So the first part, I'm going to write like I did on the previous one as well. This would be the function y equals 2/3 x. F of x is the same as y. That's the function there, 2/3 x, which gives us a slope m equal to 2/3 and a y-intercept b equal to 0, because there's no number after the 2/3 x. For the middle part, that's just y equals 3, which is a slope of 0 and a y-intercept of 3. It's just a horizontal line of 3, like that. That's what the green one is. The blue one is y equals -2x plus 5, which is a slope of -2 and a y-intercept of 5. So m equals -2 and b equals 5. You do not have to do this every time you do these. I'm just including this information to make it feel a little bit more relatable to things you already know how to do, because it is stuff you already know how to do. It just looks different in terms of how it's written. All right, that's why I'm putting them on there. So in terms of graphing this first one, what's the maximum value of x for this first section? 0. Okay. So if we plug in 0 for x here, what is 2/3 times 0? 0. Okay. So that would be the coordinate 0, 0. Do we fill it in or leave it open? Fill it in, because it has the or equal to underneath it. So we're going to put a point, a dot, at 0, 0. That is as high up on the x-axis as this particular function goes. So even though it has a slope of 2/3, which means if it was just graphing a normal line, we'd be going up 2 and over 3. We can't do that because it doesn't exist over here according to the restriction of the domain. We have to make it go that way. So we can't make it go up and over this way, but we can make it go down and over that way, because that would be the same slope. If you go up 2 and over 3 this way, that's the same as going down 2 and left 3 that way. It would just continue the slope going down now. So that's what we're going to do. We're going to go down 2 and left 3. If you reverse the order of both the rise and the run, it gives you the same slope. It just works it in the opposite direction. So, and then down 2 and left 3 again. Yes. Because we can't go up 2 and right 3, because the highest value of x is 0. We can't go past it. And so what I'm saying is, if you reverse the order of both rise and run, it gives you the same graph. It just helps you work to the left instead of the right. Down 2 and left 3 is the same thing as up 2 and right 3. Because if you did that, it would end up going like that. So if you reverse both directions of the rise and the run. The restriction? I got you. Okay, so we'll get our line through there. I'm just going to freehand this one. Okay, there we go. That's the first part. Try to dry that off. Okay, and then pink. That's the first part. The middle part. The y value is 3 for all values of x between 1 and 3. So if you go to 1 on the x-axis, the y value is 3. If you go to 3 on the x-axis, the y value is still 3. Yeah, horizontal line. So if you go over 1, you're going to go up 3. 1, 2, 3, right here. And it's going to be closed because the inequality symbols, by the way, every point on here will be a closed dot because all of them have the or equal to portion on the bottom. So nothing will be an open circle here. And then so the left part is 1, the right part is 3. We're still going to go up to 3 though because the function just says 3. So 1, 2, 3, up 3, 1, 2, 3, and then horizontal between those. Just like we saw on the warm-up, actually. The explore activity had this similar section, but it was at the end of it. And so this is the green bit here. A little bit. And green. Okay. And then the last part says negative 2x plus 5 for all values of x that are greater than or equal to 4. So what value of x do we need to plug into that function? 4, yeah. Negative 2 times 4 is negative 8. Negative 8 plus 5 is negative 3. So when x is 4, y is negative 3. So that gives us the point 4, negative 3. So if we go over to 4 and then down 1, 2, 3, that's where we're starting this last section right here. And this one has a slope of negative 2. So from that point, we're going to go down 2 and over 1. And then we're going to listen to the lawn getting mowed while simultaneously drawing an arrow at the end of it. That's our blue one. There we go. So those are the 3 parts of our piecewise defined function. Now, question? Yeah.
The restriction of 4,
Yes.
Go down 3.
Down 2. Oh wait, down 3 on the y-axis, you mean? Because the x value is 4. So this one starts at an x value of 4, but we need to know where the y value is for that as well. So we plug 4 in here. Multiply negative 8, add 5, negative 3.
Okay.
So when x is 4, y is negative 3, which gives us the coordinate 4, negative 3. Yeah, and that's the starting point for that section of the graph. From there, we apply the slope of negative 2. Okay. Now we have to determine our domain and range and the other things on here as well. Actually, let's go to the x-intercept and the y-intercept. Let's just do that. We'll start there. We'll come back to the domain and range. The x-intercept, where does this cross the x-axis? 0. How about the y-axis? 0. For values of x that are less than 0, is the function increasing or decreasing? It's increasing. Yeah, as you go left to right towards 0, right? It's going up. Yeah. If you look at the graph from left to right, so we're not talking about end behavior. End behavior is like as x goes to negative infinity. We're not talking about as x goes to negative infinity right now. We're talking about from here to here, is the graph going up or down? Going up. So it's increasing.
Wait, so left. We're looking left is going.
If it's asking you about increasing or decreasing, you are always looking left to right. The only time, let me put this up a little bit, the only time you will look at it from right to left is for end behavior as x goes to negative infinity. That's the only time you look at it from right to left. Every other time you're going that way. Okay, so we are increasing on that interval. Between 1 and 3, what's going on? Same, yeah. Constant would be the word for that. The mathematical word is it is constant. It's not increasing or decreasing. We've got constants. And then after x gets to 4, once x gets to 4, is it increasing or decreasing? Decreasing. All right. Now let's go back and figure out our domains and ranges here. Great question. Let's do it. So first thing I'm going to recommend is you are allowed to use whichever form you want to. You could use interval notation. You could use set builder notation. You could just go with standard algebraic notation. I am going to do this in interval notation. Because for me, in my brain, it makes the most sense to use interval notation. If your brain says, no, I'd rather use another one, write down a different one on the paper. So from negative infinity to 0. We're talking about the x coordinates here, right? So it goes from negative infinity to 0. Is there a gap between 0 and 1 on the x-axis? Yes. There are no points between here and here on the x-axis, right? So the first interval here in interval notation is going to be negative infinity to 0. It stops. It then picks up again where on the x-axis and goes to 3. And then it stops after that. So there's a middle interval here. So the union, bracket 1, comma 3, bracket. Between 3 and 4 on the x-axis, there is nothing. But then it picks up again at 4. So another union. It picks up again at 4, including 4. So bracket, comma, and then it goes forever, infinity. That's our domain.
Okay, that makes more sense.
Infinity on the right, negative infinity on the left. Yep. So we over here we start at negative infinity. Over there we go to positive infinity. All right. Now the range is going to be a little bit trickier because there's some overlap here. However, does this go down forever? Yes. So we are going to start with negative infinity. And it is unbroken on the y-axis until it reaches what value? 0. That's where this one's a little trickier. Between negative infinity and 0 on the y-axis going up this way, there is no gap on the y-axis. There's no gap between here and here because this line exists between those 2 points on the y-axis. So there is no gap between negative infinity and 0. There is a gap between 0 and 3. But there's no gap between 0 and negative infinity because it's continuous all the way down. So we can basically ignore that part for the range and say negative infinity to 0. That's our first section of our range. So negative infinity to 0, we include 0. And then there's a union. And then where does it pick up after that? Just 3. Does it go to positive infinity? No. Does it go to negative infinity after that? Once it gets to 3, no, it's just 3. So 3 in a bracket. That's it. Because it doesn't keep going up. It just goes to 3 and then the next problem. That's it. That's the range. Yeah. It's just those 2 parts because it doesn't keep going up after that. That's the highest point. Range is just the y values. Yeah. We already did all the x value business up here. What's what? No, it's just from left to right. And then this is from bottom to top. Okay. All right. We probably should because we only have 3 minutes left. That's not enough time to do the next one. We'll pick this up tomorrow and we'll finish this